In this video, we're going to talk about two different types of errors that we can make when we're doing hypothesis testing. We can make a type 1 error and we can make a type 2 error. When we're doing hypothesis testing, we've talked about this before, we're not proving something. We're showing the likelihood of finding a certain result given a null hypothesis. So we're really just showing probability. We are not showing certainty. And so because of that fact, we can be making errors. So we're going to talk about type 1 and type 2 error in this section. We're also going to talk about alpha, that preset level that we set, the critical boundary. We're going to talk about what alpha has to do with error. So hypothesis testing, as we've talked about, is an inferential process. We use a little bit of information that we have from our sample to draw conclusions about a population. But every decision comes with some risk of making the wrong decision in two different ways, type 1 and type 2. So type 1 error happens when a true null hypothesis is rejected. So the null hypothesis says that the sample mean and population mean, for example, are the same. We make an error when we reject that, when in actuality that null hypothesis is true. It's a big problem because basically the researcher is saying there is a treatment effect when in reality and when in actual fact there isn't a treatment effect. So risk of type 1 error is determined by alpha level. So that is under the experimenter's control. I can make my critical regions smaller by choosing a smaller alpha level. I can make the critical regions larger by setting a larger alpha level. That is under my control. And although finding a sample mean in the critical region is unlikely, it doesn't make it impossible. Just like in the very first video where we drew 10 red cards in a row. That is still possible in a regular deck of cards. It's extremely unlikely, but it is still possible. And so whenever we are rejecting a null hypothesis, we're making a risk that we're making a type 1 error, that maybe we are wrong. When we set our alpha level at 0.05, we're pretty much accepting a 5% chance that we're making a type 1 error. So this is a table that kind of explains error in a little bit greater detail. So if you look at the first decision that you can make to reject the null hypothesis, if we reject the null hypothesis, in other words, we're saying there is a treatment effect, but in reality there isn't a treatment effect, we're committing a type 1 error. If we reject the null hypothesis and there is a treatment effect, it really is true in the real world, that's a correct decision. Now we're also going to talk about a type 2 error, and that can be made when we fail to reject the null hypothesis incorrectly. So let's take a look and see what that means. If we fail to reject the null hypothesis and there is no treatment effect, that is a correct decision. But it may be the case that we fail to reject a null hypothesis, but there really is a treatment effect. And when we do that, that's called a type 2 error. So type 2 error is failing to reject a false null hypothesis, but there's lots of negatives in there. But a treatment effect was there. I'm going to show you a picture in just a moment that'll make this clearer. In other words, with a type 2 error, there was a statistically significant finding, but we weren't able to detect it. And there's not a single cause for that. So sometimes the size of the treatment effect is just not great enough to really show a difference. Sometimes our sample size is too small, and therefore we can't detect a difference. Sometimes our test is not subtle enough to pick up nuances. Maybe it's just too crude of a test. When we're talking about type 2 error, we use this symbol right here. You don't need to know the symbol, but just in case you see it in future classes, it is the symbol for type 2 error. So here's that illustration I was just mentioning. Some of you who are in nursing know about false positives and false negatives in medical tests. So this picture on the left is an example of a type 1 error. The doctor is saying to the man, "You're pregnant." Well, the man is clearly not pregnant. So type 1 error is saying something is there when it is not. Saying that a difference exists maybe between the sample mean and the population mean, when in reality it just is not true. That's a type 1 error. Now the type 2 error is pictured on the right. The doctor is saying to the woman, "You are not pregnant." The woman is clearly pregnant. So a type 2 error is missing something. Something is there, but our tests were not able to pick it up. So whenever we're doing hypothesis testing, we can make one of these two errors. These two errors are possible. So let's do a learning check. The best definition of a type 1 error is what? Go ahead and pause the video to read these 4 options. Well, first of all, we can just get rid of A and C altogether because, as I mentioned before, we're not rejecting or accepting a true or a false alternative hypothesis. Just get rid of alternative hypothesis in this whole calculation. So is type 1 error rejecting a false null, or is it rejecting a true null hypothesis? And the answer is it's when we reject a true null hypothesis. The null hypothesis says there's no difference. And if we reject it when there really was no difference, we are saying something is there when in actuality it's not there. That's a type 1 error. True or false, there is nothing the researcher can do to control for type 1 error. It just happens. Well, that's actually false because I set the alpha level. I'm setting the critical boundary as the researcher. I do this ahead of time. It's my responsibility to make my critical boundary, my alpha, small enough to avoid making a type 1 error. If I make my alpha, let's say 0.40, that means there's a 40% chance I'm going to be making a type 1 error. That makes my alpha level a lot bigger, so it makes it easier for me to reject the null, but it makes it easier also for me to make a type 1 error. Okay, so in the next video, we're going to talk more about alpha's relationship to error.